Hey guys, me again, and today we have a massive power amplifier. I was just waiting for the day that one of these was going to pop up over here, so the day has come. As you can see, it's a pretty hefty unit. We have quite a bit of stuff going on. We got the same thing on the other side. So the complaint is magic smoke came out of the unit and now it doesn't work. So what I did was I plugged it into my auto transformer that's connected to my isolation transformer. I got the dim bulb going, and if we try to power it on, nothing. So I'm almost certain that the fuse on this thing has popped as well, so that's gone. That's gone south, and that's the main fuse on this thing, so that's not a good sign. More than likely we got some cooked transistors here. I don't know exactly which side it is, but one of them, it's one of these sides, they're cooked. So we're gonna open this unit up, and well, actually before I open it up, I'm gonna spin this thing around and I'm gonna look in the back and I'm gonna see how the big main fuse is holding up. So let's start by doing that. The main fuse, which comes out of there, it says 3 to 7 amps, 250 volts, but I believe this unit is rated for 120 volts. And here's the main fuse holder. As you can see, those two fuses are cooked. They are no good. This one is very evident that it's no good, and this one also no bueno. So we're gonna have to dig into this, and we're gonna see what's going on with this thing and why it's always popping the fuse. So, oh, there goes that one on the floor, but both of them are toast. They're no good. And this one as well. No bueno. So we're gonna have to open this thing up, and it's just going all over the place, my god. We're gonna open this thing up and we're gonna replace the, it says 250 volts, but it says 3 to 7 amps. I'm not sure why there's two types. So we're gonna see what this is all about, and also we're gonna open up the top and we're gonna see if we see any evidence of damage anywhere. So let's go ahead and start by doing that. So just to show you guys, these are the right fuses. So this is supposed to be a 7 amp fuse that's in there. These are the fuses that he had used. So there's two of them that are 8 amp fuses, and you can see the thing. This is one of the 8 amp fuses right here. See how that's nice and it's colored. So this is the one of the 8 amp fuses, and the other two are 7 amp fuses. We have two good 7 amp fuses, and I'm gonna make sure when I power this on, we're gonna have it on the dim bulb, and that's probably gonna glow really nice and red, and we're gonna see what's gonna happen. So I'm gonna put the new ones in, discard those ones, and we're gonna take it from there. Here's 7 amp fuses in. I thought I would just show you what happens when I turn on this thing. So yeah, the front power button is here. Take a look at my dim bulb. Yeah, so it's going crazy because more than likely two things. The inrush current is very high on a unit like this. I'm not surprised. And other than the inrush current, we still have that short. So yeah, so until I know for sure that the short is gone, then I'm gonna try again and see what happens. So let's start by opening the top and let's take a look inside and see what's going on. Alright, so we are back, and as you can see, we already have quite a bit going on. So basically what I did was I took some time to do some small troubleshooting, and I'll show you guys what I did. So this one is a working channel. This one has no shorts in it, and I'll tell you how I knew which one was bad and which one wasn't. So I have my meter right now in ohms mode. So if I go ahead and put my probe on the circuit board, there's the V plus and then there's the V minus, and there shouldn't be a short between the two. So if I try to do this, see if I can tell you exactly what I read. If I don't know if you can see my multimeter, but basically what I just did now was I have my two probes on the plus and minus supplies, and I'm reading 175.3 ohms between these two connections. So you probably may or may not see that between here and here, these purple wires, I measure 175 ohms, and on the working channel I read open, which is a good sign. So here we have a short on this power amplifier module. So this is going to be the side that's affected. This one isn't. And I read my voltages. I saw plus minus 85 volts, which is what the service manual spec says. So yeah, we're going to tear apart this thing, and we're going to see which set of output transistors has fried. And we're going to see if we can get replacements. It's probably not going to be cheap, but we'll see what we can do. So I'm going to take this thing off, and I'm going to focus on this board here so far. And yeah, we're going to see how we progress. And also just to show you, just to prove to you guys, because probably a guy going to be in the comments saying, well, you don't have it on power. Well, just to show you that I have it on power, there's the cord plugged into the back of my power strip over there. And the lights are on the front unit. So there's our green light, our clip indicator. So it's working, and that's the good channel. This is the bad channel. So we're going to tear this one apart and see how we can progress back. So quite a bit has happened. Basically I tore into these power transistors, and they're all gone. So the power transistors and the drivers as well on the bottom, took them out because I wanted to check them out. And so this is our pile that we've come up with. So all the drivers are okay, thankfully. I tested them. These are the working power transistors, and these are the broken power transistors. So these ones measure short, and these ones are all good. So the NPN transistors are these Motorola, the 21s, yeah. S something, blah, 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 whatever, 52, 1A. And then the PNP transistors, which should be this one, no, should be this one, yeah. So this is the PNP transistor, 22. So we have three NPNs and one PNP, and those ones, it's whatever the rest it is. So those are bad, those are good, and those are good. So what we're probably going to do is we're going to tell the customer what we found, and we're going to see what he would like to do. He already dug into this, really, and there's also one thing I noticed is out of all the 8 transistors, we only have 2 insulators, which is not good, because every single pair of transistors, power transistors, for this particular package, and even for the drivers, they all need a insulator. So it could be mica, this one is mica, it could be a special rubber. So the drivers all have them, so they're there. They're like, look like copper, but those are insulators. So they're all there for the drivers, but for the actual power transistors, we are missing 6 of them because we only have 2 here. But what I will end up doing most likely is I already have some over here, because I got this a while ago, and I have both types. I have mica, and I have this like rubberish whatever thing. So I'm probably gonna put the rubberish one because that's a bit better quality. And yeah, we're gonna get in touch with the customer, and we're gonna see what he says. So we have to order, if I can get matching pairs, that'll be very nice. I'm gonna see if I can get 4 of those, and hopefully we can get away with those ones already. And it doesn't seem to be any other issues, but I'm gonna have to check. So in terms of the rest, everything else seems to be okay. Yeah, like there's no serious problems happening over here on the board. So we're gonna have to double check, but so far so good. And yeah, I'm gonna get in touch with the customer, and we're gonna see what he says. And when I get word back from him, I'll come back to this video. Okay, we are back. So quite a few things have once again happened. So the last clip, I believe I was talking about the output transistor. So basically, I informed the customer about what I found. So if I showed it last time, I don't know, but basically we have 4 transistors, and they're here. They're bad. They're no good. And I managed to find the insulators were actually there. Just it was covered and like really stuck on there. So that's why it's odd. And yeah, you see I have the X marked for bad. So these are the bad ones. It's 4 of them, and it's always, when you deal with this crap, it's always dirty and, you know, this insulating stuff. So anyways, it's in here for a reason. So these are the bad ones. And this is the good channels. This is the good channel, this is the bad channel, just to show you as a comparison. So what's gonna end up happening is I'm actually gonna replace all 8 of these transistors, and the reason is because they need to be matching specs. So if I understood the diagrams correctly in the, you know, the schematics, I can't just have 4 of one thing and 4 of another. It has to be all the same brand, same manufacturer. So the ones that I'm going to be putting in the output transistors, they are the MJ15022 and MJ15023, which are really close to this apparently, so we shouldn't be expecting a big difference in the quality or levels and stuff like that. So yeah, so I'm basically going to be replacing all 8. Because if I replace only the 4 of them, I don't know if we're going to get, you know, the quality that we're expecting, and characteristics and stuff like that might be a bit off. So that's why I'm replacing all 8. Unfortunately, it turns out that these transistors, actually, if you look very close at them, these numbers are Bryston specific numbers. Or at least, you know, when you try to look, the only things that will show up if you put these numbers on Google, for example, they're going to be the fakes that are all over the internet. So obviously I'm not going to be putting fakes in this unit. I'm going to put genuine parts. Yeah, and on this side, as you can see, everything's been pretty much been taken out, and I already gave a quick clean. One thing that I did realize was, these are the drivers for the transistors, and these are NPN transistors. These ones, the cross reference is actually already given in the service manual, E14 whatever blah blah blah, and it returns to a MJ150 29 and, or sorry, 30 and 31. And the problem with this side I found was one of these two actually tests okay in terms of being shorted or not, but the characteristics are actually a bit low. So I'm going to end up replacing these 2 NPN transistors with one of these guys, or both of these guys. These are the MJE15028, and I did some measurements and some testing, and these should work for the broken side. Yeah, so we're gonna give that a shot. Again, we're gonna replace all 8 outputs just to be safe, because again, from what I see, you know, because I have 4 PNPs and 4 NPNs that are busted, they're shorted. Yeah, and what's it called? Basically, we're gonna replace all 8 outputs, and hopefully that fixes the problem for this guy. And we're gonna replace 1 or 2 of these drivers for that side. One thing I will do here is I will more than likely clean this up, because thermal paste is going dry. So I'm probably going to clean that up and put a new amount of thermal paste for him. I'll have to see. Yeah, maybe I might do that, because that's what I'm doing here. So yeah, we're going to do that, and when parts come in and things happen, I'll resume the video. Okay, so it's been actually quite a bit some time since I last filmed about this big brute. Basically, actually now I'm gonna give a heads up. It's fixed. I fixed it all up. I got it working again. Unfortunately, I couldn't really film it because it would have been too long, and you know, I don't expect anybody that's gonna watch a video like that, you know, for maybe an hour or 2 on end. and I don't edit my videos really that well, so I film it for the time being in bits and portions, and when I actually start editing stuff and, you know, maybe putting some commentary, I'm gonna do it a bit more professionally then. But anyhow, so as always, even though I didn't film me working on it necessarily, I'll tell you guys what happened with this unit. So basically, once again, I'm not even sure where I left off. I think the clip that I left off was showing one of these modules taken apart. Basically, the customer came to me with this unit and said that one module was completely bad, like it kept blowing the fuse, the mains fuse over here. This is the mains fuse, and it kept blowing the mains fuse over here above the socket. So there's two fuses in here, one for this side and one for that side. So one of the two fuses over here kept blowing. I'm not sure about the ones inside because there's two there and then there's two over there. Probably can see those over there. So those are two 8-amp fuses, and these are two 7-amp fuses. I know that sounds weird, but according to the design and what's printed on the silkscreen, this is what it calls for. So, with all that being said, basically what it came down to was we had on, I think it was this one, 4 output transistors were shot. 4 of them blew up and shorted out, so we had to replace them, and I checked all the other components, the drivers and this board here, the extended boards here as well, and there was nothing really wrong with them, so I didn't do much to that. I just left it as is. What it really came down to was just these transistors here. So what ended up happening was I replaced all 8 of them, because the original ones are not, you cannot find them anywhere other than fakes, because there's tons of fakes online. So the original part numbers, when you look them up, there's no more, or there's no one selling anymore genuine parts for that. So basically what I did was I did a bit some research, and I read what other people were saying. The transistors that are in here now are very close to the original ones. They are the MJ15023 and the 15022 that are in here right now. They're like 16 amps at 250 volts or something like that. So anyways, they're pretty beefy transistors. I don't remember exactly the specs. I have the datasheet on my computer, but anyhow, so these were all replaced, and 2 drivers, I replaced them as well as a precaution, because the specs, I didn't like what I was testing. So as a precaution, I replaced them, and I replaced them with MJE 15033 NPN transistors, if I'm not mistaken. So again, those were readily available. Everything I bought, parts, I got them off Dishiki. Dishiki had all the parts. And on this side as well, this is the working side. So this one, actually, I didn't replace any parts. The only thing I did was I cleaned up the entire heatsink. I took all the parts off, cleaned up the heatsink, and I put new thermal paste, and I put a new insulator on the output on the power transistors. I reused the ones for the drivers because they seem to be pretty okay. It was really just the mica insulators on the power transistors, so I replaced that. And these ones, again, kept insulators, but I replaced the thermal paste, so there's fresh thermal paste on them now. And the same thing on the other side. I replaced all the outputs, like I said, because they were blown anyways, so they were replaced, and I put new insulators, and I put new thermal paste. And basically, the unit is working. I did the bias adjustment, and I did a DC offset adjustment. And this, I'm just going to show you guys one thing, because it stumped me a bit in the beginning, but then I eventually worked my way around it. The bias adjustments on, not even just this unit, but in general, Bryston units in general, the way it works is on a couple of these models, on the boards over here on the side or wherever it's located on yours, you should have 2 test points, two pairs of test points up here and down here. Those 2 little, it says C test point 2, so you should have that, and you should have this here where my probes are hooked up to right now. on each block that you have. And to do the bias adjustment, you have to connect your probes on those two prongs, which they go to basically across this big resistor here. This is the emitter resistor, and it goes across those two legs, and it measures the drop across it. And this is in millivolts. This is not in volts. So be very careful, because if you saw this over here with your multimeter selected here in volts, then there's something really wrong. So you should be only seeing for this unit around 10 millivolts per pair, and this is what the guy actually at Bryston, because I ended up calling Bryston asking about these test points, because the service manual wasn't really good at explaining it, and explaining what it was doing. So I ended up calling Bryston tech support, and believe it or not, after all these years, this unit came from around 1991. They were still able to answer me. Someone picked up the phone. I don't remember the gentleman's name, but I should have. I'm ashamed to not remember. But I told him I have this model and that I wanted to know about the test point situation. And he knew right away what I was talking about. So he was saying, yeah, I don't know why the service manual says that. And he says you should do it exactly like this. So you put your two probes across the two leads that are on the board, and you measure your drop like that. So I biased this, and I also adjusted the DC offset. And he told me, of course, obviously DC offset, no matter what, you want to keep it to 0 as much as possible, but the bias on this unit is around 10 millivolts. So he said, as long as you see around 10 millivolts on each pair, then you're okay. So that's exactly what I did. So it's at 9, but give or take, you see it's oscillating around a bit. So it goes up to 10 and drops down to 9, and it's really darn close. So this is all biased, and it's just warm to the touch. It's not boiling hot, which is important. If your heatsink is boiling hot when you're doing any adjustments, then you have the wrong bias settings. Same thing on this side. It's just warm to the touch, not hot, just warm. And that's what you want to see. It's basically the transistors are conducting, but they're not quite working yet. So you want to see this. And again, it's just warm. I can keep my hand here as long as I want, and I'm not going to burn myself. So that's again a very good sign. Same thing with this side. So yeah, anyways, I thought I'd just show you guys, but that's pretty much it for this amplifier. There's my oscilloscope. I didn't put my waveform in here because I'm using my phone to record, but we get our 440 hertz or 20 kilohertz or whatever it is, and the amplifier is back in order. So I'm gonna contact the customer and tell him it's ready to be picked up, and let him decide whenever he wants to come and pick it up. Otherwise, that's pretty much it. Everything else is working. It was really just this channel here and a bit of cleanup, and it's good to go. Oh, actually, one thing that I realized was this is something 12-volt Vids, the guy that I watch, actually, he had one of these power amplifiers in his shop, and I'll put a link in the description, the video that he made, but it's about these front lights. And according to whatever to the unit he got, the owner of his unit that he saw in the shop, those front lights, they would be blinking when there was music being played, and supposedly they're not supposed to blink. And I can vouch for that person, whoever he is, because when I was playing music through this amplifier, these lights were solid. They did not blink. So I don't know what's up with that. One thing though that I will say is that this unit is not the same revision, if I'm not mistaken. Yeah, I don't think it was this. It's not the same revision as the one that he saw, 12-volt Vids, the one that he had in the shop for repair. This is a slightly different revision. This is from November of 1991. And the back over here, it's NRB Bryston 4B. So it's a different revision. They made a couple revisions of this amplifier. So it's not quite the same, I think, the one that he saw. But again, the owner said the lights shouldn't be blinking, and on his, when he played music, it blinked. But this one, when I was playing music, it wasn't blinking. So I don't know. I really wouldn't know what the problem is with that. Maybe that I see there, because this one has that. If it happened on this, I would have suspected that IC would have been maybe faulty. So, but anywho, we don't have that problem, thank the Lord. So I'm gonna leave it at that. And yeah, our bias, as you can see, it goes down. It goes up and down. So that's why you have to have a bit of tolerance. There's one thing you want to know about this kind of stuff is that it's never gonna be exactly on point. You need to have a bit of room for diagnostics, but I actually meant to say room for error. But anyhow, we're gonna leave it at that. If you guys liked the video, please leave a thumbs up. You're more than welcome to leave a comment down in the bleep bloop section below, and make sure you subscribe to the channel and you hit the bell so that you never miss a new video when I upload one. And until next time, take care, guys. See ya. Bye bye.